Hello and welcome to one of my Python tutorials where today I will be going over the Edexcel 2019 exam paper, paper 2 for the GCSE Computer Science. But before I do, please remember to click that like button on this video, subscribe to my channel and share my channel far and wide. Without further ado, I'm going to go into each question on the paper, particularly the programming ones. So with a paper like this, we need to answer all the questions requiring a written answer. There may be more space than you need, and with programming languages, it'll either be Python, C#, or Java. In this case, it has to be used. So they're one of the three languages you would have been taught throughout the spec, depending on what school you're in. So paper covers Python, C#, and Java. So let's have a look at the questions. So some questions must be answered with a cross in the box. So nice and easy stuff. We've got to use one programming language throughout the whole examination. So it could be C#, Java, and Python. In this case, it's going to be Python. So let's have a look at the questions. Question 1, computer programs use different programming constructs. We'll go identify the most appropriate data type for the value of 4.5. Process elimination. It's not a string, string's words. It's not a character, character can be a letter. And it's not going to be Boolean, which is true and false, so it's a real. Real is decimals. Next one, give a definition of a logic error. So that's a type of error where all of the program works and produces an unintended result. Right, let's get into C. So we need to open up Q01C in the code editor. So the program will print out a counter and a counter with a 7 added to it. There are 3 errors in the code, so we need to look into the file like this. I'm going to copy and paste that over and into there. So what we have to do in this is find 3 errors in the code, and we've got to amend and correct the errors. And then we've got to save the amended code as Q1C finish for the correct file extension for the programming language. So I can see there's an error right here. There's in a while loop. You have to end it with a colon. So that's 1. We've got the count equals 0. So what we will need here, we don't want a comma. We want count equals count plus value. So the comma was 1. Was one of the errors, so we needed an equals instead. Constant value hasn't actually been declared. Okay. So let's have a look and see what we have. So we need a constant value. So constant value is going to be a 7. So we needed to have declared that. So if we're to run it, right, we can't actually do anything there. Because what we've done is because we've got some of the code the wrong way around. So if we were to look at a mark scheme, yeah, you could have count, comma, count, and I thought it'd be an equals, but it's actually not. So I'm going to run that. So what that's supposed to do is the first count does the index, and then the count plus constant value is going to basically add 1. It's going to add the constant value to the count. So 0 plus 7 is 7, 1 plus 7 is 8, 2 plus 7 is 9, 3 plus 7 is 10, 4 plus 7 is 11. So that is essentially the task. So that is that. D, oh look, give one reason why computer programmers should use comments in their programs. So if we go back up to that mark scheme. So it explains how the program works, and you can improve the readability of the program. And you can also make the code more understandable. Okay, so that is that part there. E, describe the difference between a local variable and a global variable in a computer program. So global variables, you create those in a main program, and local variables are declared inside of a function or a subroutine, and they'll be in blocked code which is indented brackets, and they're only accessible there in that subroutine in the case of Python. So now I'll see the other one. Question F, we need to get Q01F now. So if I was to go into here, I'm going to upload the file. So, like what I did before, I'm going to go into this PC. I'm going to find 1F. So 1F. So in that one, we're essentially going to copy this code and we're going to paste that in. So you can see we've got a few bits missing. So we need to amend the code to complete the if statement used to produce the following outputs as described in the table. So the shop income is more than 5,000, or the sales assistant has sold at least 10 pairs of shoes. So we've got shop income, sales assistant, assistant sales. So what we need is shop income to be more than 5,000. So greater than 5,000, or assistant sales is going to be 10 or more. So greater than or equal to 10. So that's the assistant bonus. And then what we'll need is the same, but for 2005 pairs. So we could just copy that in and paste that here. So 2000, and we got 5. So if I was to run that, we've got the shop income and the assistant sales. So the assistant bonus is 50. 4,811. That's going to be 100%, 50, then there's 50. So that should be the outcome there. So if we were to have a look at the mark scheme, just to be sure, which it is, just go and let me find it. Right, what we should have had was the AND. So change the operator. And then what we should have done was set of brackets in each of these. Is what the mark scheme would have wanted. So this is what we wanted there. So that should work as intended. And that is question 1F. So you need to save the amended code as Q01F finished. correct file extension, so usual drill. Then G, car registration codes, consists of 7 characters. Characters are 2 uppercase letters followed by 2 numbers and then 3 uppercase letters. So these 3 are valid codes. All codes need to be validated. So we've got to complete the table to show 2 additional validation tests. Each one give one example of erroneous data. So the example give should fill only that particular test. So it says 7 characters. That's not 7. So if we were to have a look back at that mark scheme, so the 3rd and 4th characters numerical digits? Nope. So that would be the 4 C's and 3 B's. Are there at least 3 characters letters or uppercase letters? Nope. So those 2 would be erroneous there. So exactly 7 characters. First 2 characters are letters, 3 and 4 are numeric, and the last 3 are letters. So that's the type of additional guidance that they would be given. Okay, let's get ready for the next one. Number 2, Anna has a 5-year-old daughter, Beatrice, and a 14-year-old son, Graham. Anna wants to program a guessing game for Beatrice to play on the computer. The program will generate a random number between 1 and 10. Beatrice has to guess a number, and the pseudocode contains the logic required to create the game. So we need to write a program and I'll implement the logic in the pseudocode. So we need to open 2A in the editor. So I'm actually going to go find it. I'm going to go over there. And I'm going to copy. Whoa, sorry. And I'm going to copy that in there. So what I'm going to do, I'm going to copy that. I'm going to paste that in here. So that is the code we need. So that is that nice little skeleton there. So what do we need to do here? Let's initialize some variables. So counter, I'm going to do that to 1. Counter to 1. What do we need to do there? Set answer to random. 9 plus 1. So we could have randint. Zero to 9. And then guess is equal to 0. So we got randint. Right there. And then we want to basically ask you to enter input. So the random number has to be 1 to 10 inclusive. So it'll be 1, 10. So now we need to take a guess from the user. So the way we do that enter a number 1 to 10, so we're going to do guess, and we're going to say enter the number for the user from 1 to 10. So enter a number from 1 to 10. So that's what we want there. So we want that little input. And it's going to receive the guess from the integer. So now we need to create a while loop to check the guess. So while guess is less than answer, or guess is greater than answer, this is where we're going to get into the statement. So that's where we're going to get in. So we got guess, and while that's greater to guess. Or you could just have, well, guess is not equal to answer. And then while that's the case, we're going to set counter to counter equals 1. Counter is counter plus 1. Boom, simple. Then we're going to have if guess is less than answer. And then we're going to say set guess was too high. So we're going to say was too high. Try again. Which should say greater than answer, not less than. And then we're going to say else guess was too low. Try again. So we've got something there. And I'm going to ask the user to guess again. So we're going to get them to type that in again. Guess again. So that's what we want. And they're going to receive that guess, and then we're going to print. And then what we're going to do, we're going to report that, and we're going to set print. So you guessed answer, and then counter in how many tries. So if we're going to do this, I'm going to enter 11, can't do that. 12, can't do that. 0, 0, 23, 28, can't do that. So I'm going to guess 9, 8, 7, 6, 5, 4, 3. So I've guessed 3 in 13 tries. I'm going to try again. 3. I've guessed that in 1 try. I'm going to guess 4, 3, 2. So it could be any number taken from that. Okay? So that is essentially question 2a. To B, Anna's written a program to help Graham with calculations for science. So we're going to open 2B in the code editor. So let's see what's in 2B, shall we? So I'm going to open that, I'm going to do that, and see what's in 2B. So we're going to state the value of distance when the program finishes. So it looks like this is a run in it, which we can't. So that'd be 24. Give one reason why the brackets are around new speed plus initial speed. Because you need the times first, then addition. So rules of bomb. Rules of bomb mass, basically. So if we were to have a look, rules of precedence, multiplication is before addition. So that's basically the answer there. And then state the data type for the variable distance. Well, distance is an integer, because integers are whole numbers. Let's have a look. Yeah, or distance you could say is a real. As x is integer, you could even just say a real. And then if we were to go to 2b, state the value of distance when acceleration is 2.75. So in that one, it's going to be 27.375. So this is more, let's see what this is doing, which is quite boring. So we're going to move on to 2C. And let's have a look at this baby. So, as written a program that manipulates text, so we need QO2C in the code editor. So we're going to use the code in the editor to answer the questions. Identify a line number where the code has a relational operator. So relational operator will be line 8 and 10, which I always call comparison operators. Okay, identify a line number where a variable is set to a numeric value entered by a user. So it's a numeric value entered by a user. So we've got lines 14 and lines 15. So they're numerical values entered by a user. Identify the name of a variable passed from the main program to the subprogram. New message, because it calls the amend message subroutine. And we identify the name of a variable that receives the value calculated by the subprogram. Out message, which is in the amend message subroutine. Okay, we got to state the value returned by the subprogram when the user input values are educational 3 and 6. So let's give this a go. Educational 3, 6. So the number of characters is essentially 6. We're going to have a look at the mark scheme. Yep, so response starts with C, 6 letters in the sequence from educational. Right, state the purpose of the subprogram. So it's basically saying why is it there. So we can return a substring, and it's located between 2 input values. So those are the 2 things you could say for your 2 marks. Okay, question 3. So this is where we can actually write code this time, not necessarily just look at it. So I'm going to get all 3 of these up and save a bit of time. Yep, that'll still work. So, what's the question saying? So we've opened QO3A in the editor, we need to write a program to implement these requirements. So the code has to check each email address to ensure it has the @ symbol. And write email addresses that don't contain the @ symbol to an error text file, error.txt file. So this time we need to have a text file called email, because that's what's going to help us actually do the assignment. So what we can do something like this. So we need to open file. So this is where we're going to use the with open. So that's the function to allow us to open a file. And then we want to open email text. And then we want to read that as a file. And then what we need to do after that is emails, file read. So we want email. We actually want email list equals input file read lines. So that's what we actually want. So that is what we want there. And then we want output file. So we want output file, which will look like this. So we've got output file open we want that to actually append, not write. So we want error, not email. So we want error.txt and we want to append that. Okay. And then let's make sure the input file bit there is right. And now we want to find errors to write the output file. So we want for address in email list. So we want a for loop. And then we want if not a in address. And then what that's going to do, we're going to output file dot write address. And there we have that. Then we want output file and input file to close. We want output file and input file to close. So once we run it, we got some errors there. It's loaded up the errors. Because a lot of these don't have the @ symbol. Okay. So we've written a line there. And we have to use the structure given to complete the program. So we don't add any more functionality to it. Okay. Explain one drawback of using a merge sort algorithm for large data sets. So you need more memory and it's not sorted and it's not efficient. So that's the problem with a merge sort algorithm. Okay. So now what we're going to do, we're going to go on to C. So we need Q03C in the editor now. And then in that one, so we're going to delete that because we won't need it afterwards. So we need to write the code below that line. So we're going to ask a user. So we need to write a program to display a square and a cube number between 1 and 50 entered by the user. Code has to be between 1 and 50 inclusive, and we display the number square of the numbers, and the cube of the numbers with the appropriate labels, and we stop when a number is outside the range 1 and 50. So let's have a look and see what type of thing they would look for. So let's start with my value being a 1 because that's the shortest. And then we want while my value is greater than 1 and my value is 50. So that's what we want in there. So we want my value int input, enter a value between 1 and 50. So that's the next bit. So we want if my value is greater than or equal to 1 and it's less than or equal to 50. And we don't want that. So we want value, my value square. So we want value squared is, and then what we're going to have is we're going to have my value times my value and my value cubed is my value times my value times my value for cubed. And I should have done that just to show. My value, just to make sure that's right. And then print, and then that should be it. So let's have a look. Let's run it. Right, so we can't. Which is not the best thing in the world to do. So enter my value greater than or equal to 1 or equal to 50. Right, between 1 and 50. I'm going to do 4, 5, 54. So I've entered a number over 50, so that just stops. So that's what we can do there. However, we can just do my value exponent 2, and we can do my value exponent 3. And I'm going to do 4 and 5 again. So I'm going to do 4, 5. So you can see we've done there's two variations to do in squared exponentation, and the output's going to be exactly the same. Okay? And we won't need these text files anymore. So that is 3C. Number 4, encryption is used to encode data. So let's say we've got to identify the word that describes the pigpen cipher. I would say plain text. But let's see what the actual answer is. Yep, A, it's plain text. It's the original unencrypted text. B, figure 1 shows the PicPen cipher grid. So we got to complete the table to show the symbols. So we've got to use these symbols to help us. So we know that's going to be a G. We know that's going to be a Q. That is going to be, that's going to be an I. That is going to be an X. This is going to be an N. And that is going to be a U. So let's have a look at the mark scheme. Simple. Nice and simple there. Figure 2, that's another grid. State whether this set of symbol meets the requirements of a PicPen cipher. I would be saying no. That'd be my reason. Justifications, they could say yes, but I would have said no. But they're saying yes. So up to 2 marks for the correct justifications. So each letter will have has a symbol that's represented. So that's why you can say yes. Okay, number 5. So how many have we got for number 5? That is actually it. Last one. Maria's a school librarian. She wants a program to display pupil use of a library. She wants to encourage reading by awarding gold, silver, and bronze medals to 3 pupils who have read the most books. Test data has been included in the code. So open Q05 in the code editor. So this is our Q05 here. Ooh, big record. So we've got a big 2D list there. And we're going to write the code below the line. So we need to write a program to calculate and display the total number and average number of books pupils have read, the ID of pupils who have read fewer than 10 books, and the details of gold, silver, and bronze medal winners. So the program needs to function correctly, even if the number of pupils in the file has changed. So we just need to use what they've said exactly to do. Don't add anything else. So let's have a look on how they would want you to do question 5 in a mark scheme. Reason why I flick back and forth through the mark scheme is I want you to see the type of thing they look for, that they're looking for there. So I will have to get that back up. So we need to print. So pupil ID of pupils who have read less than 10 books. So we need to print pupil ID of read less than 10 books. First one. So you need 4 row in range. So len is going to be the library record. So len is going to be the library record. And then books is going to be library record int library record row. So it's going to be books. So it's going to be books in books equals int. Then we want library record row. So in this one, they just want row 3. And then we're going to do if, and you can do brackets in this one, books is greater than gold. So if books is greater than gold, bronze equals silver, silver equals gold. Gold equals books. And then we've got gold ID is row. So that is what we got there. Books is greater than gold. Then NF books is greater than silver. So bronze is silver, silver's books, silver ID row, and then bronze equals books, bronze ID is row. And anything else, we don't need anything else, so it's going to be total plus total books. So we just need total equals total plus books. There's a couple of problems. We haven't done any variables, which we will need to do. So total is naught, gold is naught, silver is naught, bronze is naught. Gold ID, so we need and silver ID is naught. So we need those declared. So we should have 7 variables, which we have. And then we need books is less than 10. So if books is less than 10, colon. So if books is less than 10, we're just going to say total number of books read by pupils. Read by pupils. And we're just going to say the total, output the total there. And then we need to print average. So we need to print out the average, which needs to go outside. So it's going to be, in this case, total divided by len. Divided by len, library record, and that's going to be a 0. And I just realized I'm in an accident. So what I should have done outside, I should have done total number outside the loop and the average. So what I should have done, but if books is less than 10, print, we're just going to print library record row 0. So that's what I should have done there. Put a \n just to show. So we've got the total number and we've got the average number outside. So now we need to do gold medal winner, silver and bronze. Gold medal winner is library record gold ID. Gold ID is just going to be a 1. So it's going to be a 1. And then a 2. There's going to be a T, \T, or we might not, we won't actually need that. Just need that. So gold medal winners. Then we're going to copy, paste that, and do bronze and silver. So we're going to do silver. We're going to do bronze. We're going to do bronze here, and we're going to do silver here. And we're going to do silver and bronze here. We're going to run that. And this is our code. And that is our code working there. So we've got the details of the winners. We've got the IDs of pupils who've read fewer than 10 books. And we've got the total number and average number of books that pupils have actually read. So that is the whole of question 5. So that's the whole of question 5 there. And let's see how much of more of the paper we got to go. That, ladies and gentlemen, is actually it. That's actually it. And that is the whole 2019 Paper 2 Computer Science Edexcel. If you liked this video, please remember to hit that like button on this video, subscribe to my channel, share my channel far and wide, and I look forward to making the next video for you very soon. Goodbye for now.